These are your notes on limiting reactants. First, let's get some vocab here. A limiting reactant is the reactant in a reaction that runs out first. In other words, you don't have enough of it. The excess reactant is the one you have enough of. Or you could say you have too much of it. You have extra. It's not going to run out. So first, let's think about this in practical terms. If you're making cookies, let's say that you have a cup of flour, or the recipe calls for 1 cup of flour, a cup of sugar, a cup of chocolate chips, and 2 eggs, and that will make you 12 cookies. You have 10 pounds of flour, 10 pounds of sugar, 2 eggs, and 1 bag of chocolate chip cookies. So your excess reactants are the ones that you have enough of or too much of. You only need a cup of flour. You have 10 pounds, so you definitely have enough flour, excess flour. You have 5 pounds of sugar. You only need 1 cup, so you have excess sugar. You got 2 eggs, and you need 2 eggs. So it looks like eggs are probably going to be what we're going to run out of first. Let's check cookies, or not cookies, but chocolate chips. We've got a whole bag of chocolate chips, and that's usually more than a cup. So we're limiting is those eggs. We only have enough eggs to make 1 batch of these cookies, which means we're only going to be making 12 cookies. All right, if we had 4 eggs, we could go through the recipe twice and we could make 24 cookies. But since we're going to run out of eggs first, we could only make 12 cookies. And so what determines how many cookies you can make? The eggs do. So we could go back and add that to our limiting reactant. The limiting reactant determines how much of the product you can make. Because once the limiting reactant runs out, you're done. You can't make any more product. All right, so let's try some of these problems. These problems are going to bring back everything that we've learned so far. So we're going to start off with writing formulas and then writing equations and balancing them, just like stoichiometry. This is a practical application of stoichiometry. So for this first one, we've got iron, and it combines with oxygen to form iron 3 oxide or rust. The first thing we've got to do is write that reaction. We've got iron is Fe plus oxygen, that was O2. And then we've got a crisscross iron 3 oxide. Remember, oxygen has a -2 charge. So I'm going to cross my 2 over from my oxygen, and then I'm going to cross my 3 over from my iron. And I got a little, leave a little room to balance it. So then to balance it, you might try to balance your irons first, but then you're going to see your oxygens kind of mess everything up. So if I balance those first, it'll save me a little time. I could put a 2 there to get 6 oxygens, and a 3 there to get 6 oxygens. So then I'm going to put a 4 here. All right, that is all, should all be a review. Now let's get to the new stuff. So the first thing we have to figure out is how much or which one is the limiting reactant. Something else I do like to do with my equation is write how much I have of things on top of the equation. So they're telling me up here in the problem that I have 10 grams of iron. So I'll write that up above the iron, and they're telling me I have, I also have 10 grams of oxygen. And this is a pretty easy one. You could probably tell without doing the math, but of course for the points you have to show your work. So I'll start with the 10 grams of iron, and you're going to change these into moles. So I'm putting my 10 grams of iron over 1. Oops. You're going to use a periodic table and find the molar mass on there. It's 56. Okay, so when I did that, I got 0.179 moles of Fe. And then you got to do it for your other reactant too. So for my oxygen, I'm going to do the same thing, except all for oxygen. All right, let's see. And then for oxygen, I got 0.313. All right, and then our next step here is to divide by the number of moles. That's the coefficient from the balanced equation. And I like to do a little shortcut here and just do it in the same problem. So I'm going to do step number 3 up here. I'm going to take this one and divide it by this 4, that coefficient from the equation. And I'm going to take my oxygen number and divide it by 3. This isn't going to give you a number to use in the equation. This whole step is just to figure out which one you're going to run out of first. Okay, so when I did this one, I got 0.0448. And this one I got 0.104. We're looking for the smaller one. Whichever one is smaller, that's the limiting reactant. So this one's smaller. That means that this is going to be iron, is going to be my limiting reactant. Okay, so you need to write limiting reactant or write LR. Okay, so you do get points for picking the right limiting reactant. And then I like to highlight this number too, the number of moles that I figured out for the iron, because that's what I'm going to start the rest of my problems with. Remember that the limiting reactant tells us how much of the product we can make. Remember when we ran out of eggs in the example, that told us we could only make 12 cookies. So this is kind of like our eggs. Once we run out of this, we can't make any more of this iron 3 oxide. So to figure out how much the iron 3 oxide we make, we have to start with this number. All right, and that's step number 4. This is what I just said here. If you want to write that down. Okay, so I'm starting with that 0.179. You could also start with the grams of Fe, like the 10 grams of Fe, but this is a shortcut. This lets you not have to convert it to moles again. So now instead of converting it to from grams to moles, I can just go right to the mole ratio step. So remember, it was 4 moles of Fe. And I'm trying to figure out how much of the product I'm making. And so it's 2 moles of the product. You always have to figure out grams. I know we're in moles, but it's not practical to tell somebody how many moles of a product you can make. It makes more sense to have that number in grams. So your last step has to be to change it back to grams. Okay, so then you look at a periodic table and add up 2 irons and add up 3 oxygens. I got 160 when I did that. Okay, so then when I plug that in, I got 14.32, but then you want to change that to sig figs and scientific notation. So then I change it to 1.43. So I moved my decimal and I made it 3 sig figs times 10 to the first grams Fe 203. All right, that'll always be your middle step. And then your last step will be to figure out how much of the excess reactant we have left. Iron was our limiting reactant. That means that oxygen here is our excess reactant. This is how many grams of oxygen we're starting with. So we want to see how many grams of that did we use. And then when we subtract, that'll be how many grams of oxygen was left over. We're going to start with the same thing we started with here. Okay, so I'm going to save myself a little time and copy and paste here. Not that much. Okay, you always start with the moles of the limiting reactant. But this time, instead of figuring out how much the product you're going to get, you're going to figure out how many moles of oxygen, grams of oxygen you used up. So it's still 4 moles, Fe. And if you go back to the equation, it was 3 moles of oxygen, 3 for the coefficient there. And then we have to change that to grams. That's 32 grams. When I solve this, I should get something less than 10 because 10 was what I started with. If you get something more than the number they give you, you know you've done something wrong here. I got 4.30. All right, and that's how much you used. The 10 was how much you were given. So then you take how much you were given, 10, and subtract the 4.30, which means that 5.7 grams of oxygen is left over. So you've got 2 steps on finding the excess. You have to do stoichiometry and figure out how much of the excess was used up. And then you have to go back to the original problem and figure out how many grams of the excess you started with and subtract. All right, let's try one more problem. This one is a good review of a combustion reaction. There's the hydrocarbon for our combustion reaction. And hopefully you remember that, I lost my 2, that it's plus O2. And that you always get carbon dioxide and water. And then you have to balance it. So the first thing you would probably do is put a 2 here to balance